Hello students, how are you? I hope you all are fine. Today let us start a new chapter on polynomials. In this chapter, we shall look into the introduction, geometrical meaning of the zeros of a polynomial, relationship between zeros and coefficients of a polynomial. We shall also study about the division algorithm for polynomial. In this episode, we shall cover the definition and types of polynomials, geometrical meaning of the zeros of the polynomial and relationship between zeros and the coefficients of a polynomial. As we have studied this chapter earlier, let us quickly recapitulate what all we have studied before. So, what is a polynomial? An algebraic expression of the form a naught x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus so on plus a n minus 1 into x plus a n, where a naught, a1, a2 and so on a n are real numbers and n is a non-negative integer and a n is not equal to 0 is called a polynomial of degree n. Now, what is the degree of a polynomial? The highest power of x in a polynomial p of x is called the degree of polynomial. We have also studied about linear polynomial. A polynomial p of x of degree 1 is called a linear polynomial and p of x is of the form ax plus b, where a and b are real numbers and a n is not equal to 0. For example, 2x minus 1 square root 2y plus 1, 2 minus u, etc. So, what is a quadratic polynomial? A polynomial p of x of degree 2 is called quadratic polynomial and p of x is of the form ax square plus bx plus c, where a, b, c are real numbers and a n is not equal to 0. For example, 5 minus y square, 4y plus 5y square, 6 minus y minus y square. So, we understand that expressions like 1 upon x minus 1, square root x plus 2 and 1 upon x square plus 2x plus 3 are not polynomials. Now, let us see what is a cubic polynomial. A polynomial p of x of degree 3 is known as a cubic polynomial and p of x is of the form ax cube plus bx square plus cx plus d, where a, b, c and d are real numbers and a n is not equal to 0. For example, 4x cube, 2x cube plus 1, 5x cube plus x square, 6x cube minus x, 2x cube plus 4x square plus 6x plus 7. Now, what is a constant polynomial? A polynomial p of x of degree 0 is called a constant polynomial and p of x is of the form k. For example, 4 minus 7 upon 5. Now, you have also studied about monomial. What is a monomial? Polynomials having only one term are called as monomials. For example, 2x, 2, 5x cube minus 5x square, y and u to the power 4. What is a binomial? Polynomials having only two terms are known as binomials. For example, x plus 1, x square minus x, y to the power 9 plus 1, u to the power 15 minus u square. What is a trinomial? Polynomials having only three terms are called trinomials. For example, x plus x square plus pi, u plus u square minus 2, y to the power 4 plus y plus 5, square root 2 plus x minus x square. We have also studied about zeros of a polynomial in class 9. A zero of a polynomial p of x is a number c such that p of c is equal to 0. For example, the zero of the polynomial x minus 1 is obtained by equating it to 0. X minus 1 is equal to 0, that means x is equal to 1. We say p of x is equal to 0 is a polynomial equation and 1 is the root of the polynomial equation p of x is equal to 0. So, we say 1 is the 0 of the polynomial x minus 1 or a root of the polynomial equation x minus 1 is equal to 0. Let us look into the important remarks. First one is a non-zero constant polynomial has no 0. Every real number is a 0 of the 0 polynomial. A 0 of a polynomial need not be 0. every linear polynomial in one variable has a unique 0 and a non-zero constant polynomial has no 0. A quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. So, with this, let us understand the geometrical meaning of the zeros of a polynomial. Let us consider a linear polynomial ax plus b where a is not equal to 0. Now, the graph of y is equal to ax plus b as we know is a straight line. For example, the graph of y is equal to 2x plus 3 is a straight line passing through -1 and 2, 7. If I put these values, see here, -1 is equal to 2 into -2 plus 3. I get -4 plus 3, right. So, these are the points where we can join and we will get a graph of the polynomial y is equal to 2x plus 3. From figure you can see that the graph y is equal to 2x plus 3 intersects the x axis at point -3 upon 2, 0. We also know that the 0 of 2x plus 3 is -3 upon 2. Thus, the 0 of the polynomial 2x plus 3 is the x coordinate of the point where the graph of y is equal to 2x plus 3 intersects the x axis. Let us see the graph. Look here, we also know that the 0 of 2x plus 3 is -3 upon 2. Can you see this point? -3 upon 2, 0. It is on x axis. Thus, the 0 of the polynomial 2x plus 3 is the x coordinate of the point where the graph y is equal to 2x plus 3 intersects the x axis. Let us see in general for a linear polynomial ax plus b where a is not equal to 0, the graph of y is equal to ax plus b is a straight line which intersects the x axis at exactly one point, namely -b upon a, 0. Therefore, the linear polynomial ax plus b where a is not equal to 0 has exactly 1, 0, namely the x coordinate of the point where the graph of y is equal to ax plus b intersects the x axis. So, now let us look into the geometrical meaning of a 0 of a quadratic polynomial. In fact, for any quadratic polynomial ax square plus bx plus c where a is not equal to 0, the graph of the corresponding equation y is equal to ax square plus bx plus c has one of the two shapes, either open upwards like u or open downwards like this, depending on whether a is greater than 0 or a is less than 0. These curves are called parabolas. Consider the quadratic equation y is equal to x square minus 3x minus 4. To plot the graph, a few values of y corresponding to a few values of x are listed here. We can see from table that -1 and 4, look here, -1 and 4. These are the points we have, they are zeros of the quadratic polynomial. Also note from the figure that -1 and 4 are the x coordinates of the points where the graph of y is equal to x square minus 3x minus 4 intersects the x axis. See it in the graph. We have here -1, 0 and 4, 0. The graph is touching the x axis at 2 points. Thus, the zeros of the quadratic polynomial x square minus 3x minus 4 are x coordinates of the points where the graph y is equal to x square minus 3x minus 4 intersects the x axis. This fact is true for any quadratic polynomial, that is, the zeros of a quadratic polynomial ax square plus bx plus c where a is not equal to 0 are precisely the x coordinates of the points where the parabola representing y is equal to ax square plus bx plus c intersects the x axis. I hope you have understood this. Now, let us look into our observations. From our earlier observations about the shape of the graph for a quadratic polynomial, the following 3 cases can happen. Let us see all the 3 cases. Case 1, here the graph cuts the x axis at 2 distinct points, A and a dash. You can see here the x coordinates of a and a dash are two zeros of the quadratic polynomial ax square plus bx plus c in this case. Let us look into the next case, case 2. Here the graph cuts the x axis at exactly one point, see, point A, that is the two coincident points. So, the 2 points A and A dash of case 1 coincide here to become one point A. The x coordinate A is the only 0 for the quadratic polynomial ax square plus bx plus c in this case. Now, let us look into the third case. Here it is very interesting. Here the graph is either completely above the x axis or completely below the x axis. So, it does not cut the x axis at any point. So, the quadratic polynomial ax square plus bx plus c has no 0 in this case. We can see geometrically that a quadratic polynomial can have either two distinct zeros or two equal zeros or no 0 at all. This also means that a polynomial of degree 2 has at most two zeros. Now, let us look into the geometrical meaning of the zeros of a cubic polynomial. Consider the cubic polynomial x cube minus 4x. To see what the graph of y is equal to x cube minus 4x looks like, let us list a few points values of y corresponding to few values of x as shown in the figure. Here you will be observing that minus 2 0, 0 0 and 2 0. These are the points where the graph will touch the x axis. Locating the points on the table on the graph paper and drawing the graph, we see that the graph of y is equal to x cube minus 4x actually looks like the one given in the figure here. Can you see? This is minus 2 0, 0 0 and 2 0. The graph is cutting the x axis at 3 points. We see from the table that minus 2, 0 and 2 are zeros of the cubic polynomial x cube minus 4x. Observe that minus 2, 0 and 2 are in fact the x coordinates of the only points where the graph of y is equal to x cube minus 4x intersects the x axis. Since the curve meets the x axis at these 3 points, then x coordinates are the only zeros of the polynomial. So, any polynomial of degree 3 can have at most 3 zeros. Okay. Now, we shall look into your exercise of NCERT textbook, exercise 2.1. First question, it goes, the graphs of y is equal to p of x are given in the figure below for some polynomials p of x. Find the number of zeros of p of x in each case. Let us look into each case. First one, can you see, this is the x axis and this is y axis, and this is the graph of the polynomial. We can see it is parallel to x axis, that means it is not touching the x axis at any point. So, number of zeros will be here 0. In this case, can you see the graph, it is touching the x axis at one point. So, number of zeros in this case will be 1. Here can you see, yes, how many zeros it has? 3, you are right. We can see the graph is touching the x axis at 3 points. So, number of zeros in this case will be 3. Let us look into the fourth case. Here we have to find number of zeros. Can you see this parabola is touching the x axis at 2 points. So, number of zeros here will be 2. What about this case? We can see x axis is cut by the curve at 4 points. So, number of zeros in this case will be 4. In the sixth case, yes, you are right. Can you guess how many number of zeros? Yes, they are 3, because the curve is cutting the x axis at 3 points. Let us study about the relationship between zeros and coefficients of a polynomial. In general, if alpha and beta are the zeros of the quadratic polynomial, p of x is equal to ax square plus bx plus c, where a is not equal to 0, then you know that x minus alpha and x minus beta are the factors of p of x. Therefore, ax square plus bx plus c can be expressed as k into x minus alpha into x minus beta, where k is a constant, that is equal to k into x square minus alpha plus beta into x plus alpha beta, or it can be written as k x square minus k into alpha plus beta into x plus k into alpha beta. Comparing the coefficients of x square, x and constant terms on both the sides, we get a is equal to k, b is equal to minus k into alpha plus beta, and c is equal to k alpha beta. This gives us alpha plus beta is equal to minus b upon a and alpha beta is equal to c upon a. That means, sum of the zeros alpha plus beta will be equal to minus b upon a, that is equal to minus coefficient of x upon coefficient of x square. Product of zeros will be equal to alpha beta, that is equal to c upon a, or constant term upon coefficient of x square. Now, we shall look into an example to understand this. Find the zeros of the quadratic polynomial x square plus 7x plus 10 and verify the relationship between the zeros and the coefficients. We have done it in class 9. We have x square plus 7x plus 10. Here we know splitting of middle term, I can write down 7x as 2x and 5x. With that we will get the two factors x plus 2 into x plus 5. So, the value of x square plus 7x plus 10 is 0 when either x plus 2 is equal to 0 or x plus 5 is equal to 0. That is, when x is equal to minus 2 or x is equal to minus 5. Therefore, the zeros of x square plus 7x plus 10 are minus 2 and minus 5. Now, sum of the zeros, just observe, minus 2 plus minus 5 is equal to minus 7, that is obviously equal to minus 7 upon 1, that means minus coefficient of x upon coefficient of x square. Same way, product of zeros, see here minus 2 into minus 5 is plus 10, that is nothing but c upon a, 10 upon 1, constant term upon coefficient of x square. Having done this, now let us start with your exercise 2.2. What does the first question say? It is find the zeros of the quadratic polynomials and verify the relationship between the zeros and the coefficients. So, our question is x square minus 2x minus 8. So, by splitting of middle term, I need to find factors of 8 in such a way that I get minus 2x. Here itself I am getting x square minus 4x plus 2x minus 8. Product should be minus 8 and sum should be minus 2. So, what are the common factors in these two terms? X. So, I get x minus 4, here 2 is common. So, x minus 4, that gives me x minus 4 and x plus 2 as the factors. That says either x is equal to 4 or x is equal to minus 2. These are the zeros of the quadratic polynomial. Now, let us just compare this x square minus 2x minus 8 with our general expression for a polynomial, quadratic polynomial. What is the value of a? It is 1, b is minus 2 and c is minus 8. Let me write down what is sum of the roots. It is alpha plus beta, it is minus b upon a is 1, that is 2. And what is product of roots? It is c upon a. What is c here? Minus 8 upon 1. So, I get sum of the roots as 2 and product as minus 8. Having found the zeros here, let me see what is sum of the roots here. You have alpha plus beta as 4 plus minus 2. It is obviously 2. Can you see sum of the roots, and here sum of the roots here is verified. Likewise, let me find out the product. Product is 4 into minus 2. Is it minus 8? Is this also verified with the product? Can you see? Yes. So, we have verified the relationship between the zeros and the coefficients. I hope you have understood this. So, students, we have another polynomial here, 4s square minus 4s plus 1. Let us compare this with the general polynomial, that is ax square plus bx plus c. What is the value of a here? It is 4, b is minus 4 and c is 1. So, what we have studied? We have studied that sum of the roots is minus b upon a. That means, it will be minus of minus 4 upon 4, that is equal to 4 upon 4, that is 1. Clear? Now, product of the roots we know it must be c upon a. What is c here? 1 upon 4. Now, let us solve this and find out the factors and then the zeros. So, 4s square using splitting of middle term, I can write it as 2s minus 2s plus 1. Here we find we have 2s is common. So, it is 2s minus 1 minus 1. If I take common, I get 2s minus 1. So, obviously, two factors are 2s minus 1 and 2s minus 1. To find out the zeros, each should be equal to 0. So, we get 2s is equal to 1 or s is equal to 1 upon 2. These are the two roots or zeros. Now, if I find out the sum of these roots, what do I get? 1 upon 2 plus 1 upon 2 is 1. Can you see? It is very interesting to note that alpha plus beta here was also 1 and now we have found out the zeros. There also sum of the zeros is 1. Let us check for the product. We have 1 upon 2 into 1 upon 2, that is equal to 1 upon 4. What do you notice? Yes, the product of the zeros is also verified. Thus, we have seen the relationship between the coefficients and the roots of the polynomial for 4s square minus 4s plus 1. I hope you have understood, students. Okay, let us look into the next part. So, students, we have another polynomial here. See, but it is not in standard form. Let us first write down in standard form and then we will split it with the help of splitting of middle term. Now, we can write it as 6x square minus 7x minus 3. Here 6 3s are 18. So, I need to factorize it as 2 and 9. Yes, I think that will give me as minus 7x if I take 6x square minus 9x plus 2x minus 3. What is common in first two terms? Yes, you are right, it is 3x. So, it is 2x minus 3. Here obviously, if I take one common, I get 2x minus 3. Here we have 2x minus 3 and 3x plus 1 are the two factors. In order to find the zeros, I will equate it to 0 and I will get the values as 3 upon 2 and minus 1 upon 3. Okay. Now, if I find out the sum of these roots, that is alpha plus beta, I will have 3 upon 2 plus minus 1 upon 3. On taking LCM, I get 9 minus 2, that is 7 upon 6. Let us take the product also. Alpha beta will be 3 upon 2 into minus 1 upon 3. So, I get the product as minus 1 upon 2. So, I have alpha plus beta as 7 upon 6 and alpha beta is minus 1 upon 2. Now, let us verify. We have here 6x square minus 7x minus 3. When I just compare it with the quadratic polynomial, what is the value of a? It is 6 B is minus 7 and C is minus 3. So, what is alpha plus beta? It is minus B upon A. What is minus B here? Minus of minus 7 upon A. So, it is 7 upon 6. And what about the product? Alpha into beta, it should be equal to C upon A. What is C? Minus 3 and A is 6. Yes, I get it as minus 1 upon 2. So, we have seen, students, the sum of the roots is 7 upon 6, it is verified, and what about the product? It is minus 1 upon 2 in both the cases. Yes, I hope you have understood this. Likewise, you can try out the other parts of this question. Hope you have followed. Let us look into the next question now. Find a quadratic polynomial each with the given numbers as sum and product of its zeros respectively. We have already studied that x square minus sum of roots into x plus product of roots is the formula to write down when we are given sum of the roots and product of the roots. So, what is sum of the roots here? Alpha plus beta is 1 upon 4 and alpha into beta is minus 1. It is already given to us. Okay. So, let me write down x square minus what is sum of the roots? It is 1 upon 4 into x plus product of the roots, okay, which can be simplified as 4 x square minus x minus 4. So, students, we get x square minus 1 upon 4x plus of minus 1, which can be simplified as 4x square minus 1x minus 4. This is the quadratic polynomial of the given values for sum of the roots and product of the roots as 1 upon 4 and minus 1 respectively. I hope you have followed. So, students, after understanding these concepts, now it is time to take up the homework. Question number 1. Look at the graphs of the figure given below. Each is the graph of y is equal to p of x, where p of x is a polynomial. For each of the graphs, find the number of zeros of p of x. Question number 2. If p and q are the zeros of the polynomial p of x is equal to 2x square minus 7x plus 3, find the value of p square plus q square. Question number 3. Find the condition that zeros of polynomial p of x is equal to ax square plus bx plus c are reciprocal of each other. Question 4. Find the value of k if minus 1 is a zero of the polynomial p of x is equal to kx square minus 4x plus k. Question number 5. Find the zeros of the quadratic polynomial 7y square minus 11 upon 3y minus 2 upon 3 and verify the relationship between the zeros and the coefficients. Now, it is time to summarize the concepts what we have studied today. In this episode, we have studied the following points. Polynomials of degrees 1, 2 and 3 are called linear, quadratic and cubic polynomials respectively. A quadratic polynomial in x with real coefficients is of the form ax square plus bx plus c, where a, b and c are real numbers with a not equal to 0. The zeros of a polynomial p of x are precisely the x coordinates of the points where the graph of y is equal to p of x intersects the x axis. A quadratic polynomial can have at most 2 zeros and a cubic polynomial can have 3 zeros. If alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then alpha plus beta is equal to minus b upon a and alpha into beta is equal to c upon a. If alpha and beta gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma is equal to minus b upon a, alpha beta plus beta gamma plus gamma alpha is equal to c upon a and alpha beta gamma is equal to minus d upon a. So, students, I hope you have understood the concepts explained today. Please keep practicing so that you can master the concepts and you can enhance your computational skill. Thank you.